Hey everyone, it's that math magician. On this video, we're going to take another look at polygons and we're going to see, can we find the area of a regular pentagon? Now, we do not have a formula for a regular pentagon. It's not like quadrilaterals where we have all these types of formulas for parallelograms and rectangles and squares and trapezoids. Even triangles we have an area formula for. But for this regular pentagon, we don't have a formula. So we want to see, can we use any of our existing formulas to help us find the area of that regular pentagon? Remember, regular means that all of the sides on that pentagon are equal and all of its interior angles are equal. So using that information and the fact that it has a radius of 1, it's going from the center out to one of the points there, the vertices, we know that it is a regular pentagon. So here's how we're going to find the area for this regular pentagon. Notice that we have a radius of 1. And notice that if I really wanted to, I could draw another one just like that, creating a little triangle inside the pentagon. I could actually keep doing this from the center out to every vertex of the pentagon to create 5 congruent triangles inside that regular pentagon, right? Every triangle there is the same. They're kind of just being mirrored around that pentagon. And now we want to think, if I could find the area of just one of those triangles, right? Because we know how to find the area of a triangle. That's base times height divided by 2. So if I could find the area of just one triangle, then I can find the area of the whole pentagon because it's just that area times 5. So that's what we want to do. We want to see, can we find the area of just one of those triangles? Now, I'm going to draw that triangle out here by itself separate, just so I can really see it and then use it to help me solve for it. Now, we talked about it earlier. I want to find the area for this triangle. Well, in order to find the area of a triangle, I need to have base, I need to times it by the height, and then I got to divide by 2. So I'm looking at that triangle and you know what? I don't think I know the base, right? That base was this part of the pentagon. It was the side of the pentagon. That's unknown. I don't know what that is, so I'm just going to label that B. Same thing with the height. I don't know what the height of that triangle is, so I'm going to label that H, okay? What I do know, though, is that this side is 1. Okay, I do know that that side is 1. That was the information given to us. Now, there is one other piece that I can find, and it's actually going to be this angle here at the top of that triangle. That is the same angle that is right there in our pentagon. Notice that's what we call a central angle. Central angles are the angles inside that pentagon. All of those triangles meeting in the middle, and it forms a circle. That means that all 5 of those angles there are going to add to 360. And since they're all the same angle, and I want to find out what 1 is, I could definitely find out what this angle is by taking 360 and dividing by 5, realizing that that missing angle there is 72 degrees. Now look at that. I have a triangle there. It's sort of been cut down the middle with the height. I don't know the height. I don't know the base. But I do know this side here is 1. And I have that missing angle at the top is 72 degrees. Here's what we want to do now. I want to now take that triangle. We drew the height right down the middle. We're going to break it. And we're just going to focus in on one of those right triangles. It does not matter which one you decide to focus on. I'm going to focus on the one on the left. But you could also do this on the right. Because, again, I know that this side here is still 1. Okay. I don't know what the height is, so I'm going to keep that labeled as H. Okay, I don't know what the base is still, but notice I can't label this guy B because it's really not B, right? The whole B was this entire base of our old triangle. I've now cut that in half, so really it's B divided by 2, right? It's half of B. So you know what I'm going to do? I'm going to label this just as X so I don't get confused. But remembering that X times 2 is going to give us that base there, that whole base. Now look what happens to that central angle. It was 72 degrees, but then it got chopped in half, right? Our height there cut that central angle right through the middle. So now that old 72 degrees, when I divide it by 2, it ends up being 36 degrees. Look what we have there. We have a right triangle with an angle that we know, a side given to us, our hypotenuse, and we don't know the x and we don't know the h. We can definitely use sine, cosine, tangent, trigonometry to help us solve for x and for h. So let's go ahead and do it. I'm going to start with x. I want to solve for x first. X is the opposite side. I already mentioned that 1 is my hypotenuse, which means h is my adjacent. So if I'm doing opposite and hypotenuse, I think that's sine. So I'm going to set up now. I'm going to zoom over here so we can focus in on just this. I'm going to set up my sine now. So sine of my angle, 36 degrees, equals sine is opposite over hypotenuse. So that's going to be x over 1. I could put this guy over 1 so I could cross multiply. Well, x times 1 gives me x. And then look at this, 1 times sine of 36 degrees. I mean, I really don't need to write the 1, but I can leave the 1 there because really anything times 1 is just itself, right? But 1 times sine of 36 degrees, well, now's the time to get my scientific calculator out. If it actually stays open, there it is. And I'm just going to type in 1 times sine of 36 degrees to find that x there is going to be 0.588. 0.588. That is what our x value equals, 0.588. But remember, that is not what our base equals. Remember, to get the base, we chopped it in half to get x. So if I want to know what b is, I'm going to need to take that x and I'm going to need to times it by 2. So let me do this real quick. Get my answer, times it by 2, and I see that that missing side there should be 1.176. 1.176. So look at that. Remember, I'm trying to get the area of that big triangle. I now know the base, right? I'm setting up that area formula. I know that the base that's going to be on top is going to be 1.176. I just got to get my height. And I can get my height by using cosine, right? Cosine with my adjacent and my hypotenuse side. I'll go ahead and set that up now. Cosine of 36 degrees is going to equal h over 1, right? Adjacent over hypotenuse. H over 1. Same thing we just did over here, but this guy over 1. Cross multiply. H times 1 is h. 1 times cosine of 36 degrees. Again, I don't really need to type in the 1, but we will just to show that it doesn't matter. But 1 times cosine of 36 degrees is going to give us 0.809. That is our missing height for both triangles, right? Notice that I can actually just come over here and write it on the original triangle because I don't need to double it, right? We had to double x because we took that base and we chopped it in half. I did not cut the height in half. The height was always the same. But now I know what my base is and what my height is. I'm going to go ahead and zoom this over here so we can get back to the actual problem, which was finding the area of that triangle. We had our base. It's 1.176. We now have our height, which is 0.809. So we take the base, we take the height, and we divide it by 2. So let's get that calculator out one more time. Probably not one more time. We're going to need it a couple more times. I'm going to take 1.176. I probably should have put parentheses around there. There we go. And I'm going to do 0.809. Close that. Divide all of that by 2. And look at that. The area of that single triangle is 0.47. Probably should round that to 0.476. 0.476. There were no units, so I'm just going to write units squared. Now, we've done all of this work, right? It feels like we're at the end of the problem, but we're not just yet, because that right there is the area of that single triangle. If we think back to what the question was originally, it was to find the area of the pentagon. So to find the area of that pentagon, I know that one of those triangles has an area of 0.476, and I know that there are 5 triangles inside that pentagon, right? We chopped it up into 5 separate triangles. So if I want to find the area of that entire pentagon, I just got to take that answer, times it by 5, and we get that the total area for our pentagon is 2.378 units squared. Man, oh man, that is a lot of work. But I want you to take a step back and to appreciate the work that we just did, right? We did not have a special formula for a regular pentagon. We actually don't have special formulas for any of the shapes that are bigger than 4-sided shapes, right? But if you know the shape is regular and you have at least one side, in this case I had the radius, but if I have the base or if I have the height, I'm going to be able to replicate this process for any polygon, no matter how many sides it is, as long as it's regular. This will work. We just got to chop it up into triangles, use some trig to find some of the missing sides, find the area of one triangle, and then multiply it by the number of sides. That's how it's going to change for you as you work through other examples. It's that Math Magician, and I'll see you on the next video.